So I want to introduce this idea of temperature, and it'll be a bigger deal the more we go on in this class. We'll be using thermometers all the time. I got to start now, though, because there's a lot to what temperature is. Basically, temperature will measure if something is hot or cold. So that's what we're looking, hot or cold, basically. I'll make cold blue because that's okay. So that's what the temperature will tell us, whether something's hot or cold. Now, there happens to be two ways that we're going to measure temperature. We're going to measure temperatures with the Celsius scale, and we're also going to measure temperature in the Kelvin scale. Now, the range of temperature can go from 0 to infinity. Okay, because it is an absolute measurement. And what I mean by absolute, there is a point where you have no temperature. The reason for that is because not only does temperature measure hot and cold, but it is also a measure of what's called the average kinetic energy. And what average kinetic energy is a measure of the motion or the movement of all the molecules that are making up whatever it is that I happen to be measuring the temperature of. So since we're talking about this idea of motion, it would just make sense that there is this place where things have completely stopped. Well, guess what? When things completely stop, I am at 0 temperature. Okay? So this is the point that's called, it's actually called absolute 0. And it refers to the fact that there is nothing moving at that point. So down there is absolute 0. Okay? So how does this scale work, these two scales in terms of what's going on? Here's how it works. If I look at the Celsius scale, okay, there are a couple places that we're pretty familiar. One of them hits at a point. Let me do Celsius, so I'll do it in red, and I'll do it above here. Okay, so at 0 degrees Celsius, what happens then, we have, if we're talking about water, it's going to be ice. All right. The next place that we're kind of familiar with water happens up at 100 degrees Celsius. And that's when water turns into vapor. Better spell vapor right. Okay. So these are two sort of, and we live somewhere in between most of the time. Now, if I'm talking about the Kelvin scale, at 0 degrees, that turns out to be 273 Kelvin. And you don't say degrees Kelvin, you just say Kelvin. And 100 degrees turns out to be 373 Kelvin. So what you see is each incremental increase in Kelvin is the same as a degree change in Celsius, which is kind of nice. But to fill this out, it also means that absolute 0, way down here, happens at a negative 273 degrees Celsius. Very cold. People have gotten like within a billionth of the absolute 0. You'll never get there because there's always some heat transfer. We'll talk about all that stuff later, but this is what I want you to know. Now, the formula to convert back and forth is very simple. Kelvin is equal to degrees Celsius plus 273. Get the 3 in there. I don't know what happened to the 3. All right. So that's the formula for converting backwards and forwards. So like in my example, I said, okay, if I'm sitting at 273 Kelvin, that's going to equal some number of degrees Celsius plus 273. I'm going to subtract 273 from each side, minus 273, minus 273. Long and short of it, 0 is equal to the degrees Celsius, and that's exactly what happened. All right?